Patro, Scientist D, posted at Central Radiation and AWS Laboratory, Pashan, Office of Climate Research and Services, Pune, IMD. Dr. Patro did his BTech in Electronics and Telecommunication and Engineering, MTech in Applied Electronics and Instrumentation Engineering, and presently continuing his PhD at CUAP Pune. He joined IMD in August 2021. His current assignments include planning, installation, monitoring of AWS and radiation network, installation of digital current weather indicating systems, present weather systems at airports. He installed AWS on routes of Amarnath Ji Yatra during June 2022. He was an officer in charge of scientific officer at Indian Institute of Geomagnetism, Navi Mumbai, DST GOI, Government of India. He was deputed as deputy leader of 37th Indian Expedition to Antarctica, Bharati Station, Research Station during 2017 to 18, and as a member of 35th Indian Scientific Expedition to Antarctica during 2015 to 16. I now invite Dr. Sudarshan Patra to continue his lecture. Dr. Sudarshan Patra, welcome.
Very good morning, sir. Thank you very much for a wonderful introduction.
All the audience are requested to put some questions in the chat room. After that, he will be happy to answer your queries. Okay. Sudarshan Patra, you can continue.
Thank you, sir. Very good morning to all of you. Respected Somnath Datta, sir, head MTI, Dr. Hosalikar, sir, head CRS, KK Singh, sir, and Dr. Atri, sir, all the participant universities all over India, my colleagues from all over India, all the students, participants, and all my friends. Very good morning to all. With this introductory section, I would like to start share my PPT. Sir, is it visible?
Yes, it is visible.
Thank you, sir. So we will start our discussion regarding basic weather elements and their measurement. I'm Sudarshan Patra, scientist D. Sir already introduced me. Presently, I'm posted at Surface Instrument Division. It has a unit at WS Lab at Pasan. It is under Climate Research and Services. I'd like to welcome you all to the lecture series of different models of weather, climate services, and science organized by MTI, CRS, IMD. My topic is basic weather elements and their measurement. With this, we'll start our PPTs. So, the weather and the climate. First, we will start from here. What is a weather and a climate of a place? It is described by the composite atmospheric, these factors, pressure, temperature, rainfall, cloud, humidity, and visibility. These are exactly the basic factors which influence our weather and the climate. So weather of a place at a given time is the instantaneous values of these all elements: pressure, temperature, wind, rainfall, cloud, humidity, and visibility. This is the instantaneous present reading indicates the weather. And the climate at a place is the average of weather. It is a long study over a climate of a particular place. It is called as climate. It required a long series of data, years of data for the study of climate and climate change and all. So the basic weather elements, it is a precipitation, or it is called a rainfall, temperature, humidity, pressure, wind speed, and wind direction, and evaporation. These are the basic weather elements we are observing at different surface observatories all over India and in the world. So why exactly we are observing weather? For accurate and timely weather observations are essential inputs for the weather forecasting. Numerical weather prediction models require these observations for study of research and study on climate and climate change, environment protection. These all required our weather observations. And any system or all the output of our products, what we can say system output, it is depends upon the input. If we give a accurate input to a unit, we will get accurate output. So the accuracy, reliability, efficiency of a unit or a product, it is a meteorological study. It depends upon these all inputs, what we called as observations. So from the observation, we are collecting these basic elements, what we have discussed, and these are act as an input to the our models, and it will give its output according to the input we have given. So the accuracy is entirely, it is very important. The accuracy, reliability, and efficiency of its output, it is totally depends upon the observations. So observe from the word observations, it is there are two more words it is related to is observer and observatory. The place where we are taking observation is called as observatory, meteorological observatory, and the person who is involved in recording this observation is called as an observer. So who need these observations, and or we can say why it is required observation. We will discuss the following factors and the study needs. These are the observation data we are using in the following sectors: for weather forecasting, aviation, agriculture study, then tourism forecasting, insurance, sports section, then transportation, justice, navigation, national defense, city planning, and health. So for these all sections, we need our weather observations as an input for, or the forecasts are used in these sections. So IMD generally giving service to these broadly you can say the monsoon prediction, aviation services for that meteorological observations are required, then agriculture forecasting, then shipping, hydrology, transportation, power and energy section, tourism sections, health sector, sports section, then cyclone monitoring, disaster management, flood management, and then defense, pilgrims, tourism, and monitoring, tracking, and all. Then visuality forecasting. This is all very important for the transportation and aviation field, fisheries and climatology, climate change study, and urban development. So these all observed data and forecasts are used in these sections. Now, so if the section is a basic, so we will, there are various observation systems are available in our IMD, but we will discuss in this section the basic elements and its observation procedures. Okay, so observing systems may be classified in a several way, and that is mostly the surface observation and observations. So in this section, we will mostly give importance to the surface observation sections. So surface observation, we are again it is classified into two general category: conventional or non-automated observation systems. It is generally we are having that our observatories all over India, and where we are recording these observations manually. And modern automated observation systems like automatic weather stations, automatic rain gauge station, agro AW stations. So these are automated stations or unmanned station where these systems are installed at a remote locations, and the data is transmitting from that section at a different interval according to our requirement at a frequency of 1 minute. It is a resolution at 15 minute and hourly. So there are two techniques are available. By satellite, it is hourly we are getting data at our segment division and at AWS Lake Parson. And one more method is there for modern this automated observation, what data we are receiving at our at station at an interval of 15 minutes most generally during normal situation, and during disaster time it can be set to 1 minute accuracy. So we are having so many advanced observational networks also, but in basic we can discuss regarding surface meteorological network, rainfall monitoring networks, agrometeorological networks, and aviation met observation network. Then in advance we are having upper air meteorological observation, weather radars for tracking of cyclones and severe weather conditions. Then surface marine meteorological observations are also available. Space-based observations also available by satellite observations. Then airborne meteorological observation. Then we are having radiational observational network all over India, and observational ocean observational network, surface and upper air, and environmental monitoring station. So in basic, we are having this following four. We are today we'll discuss in this section: surface meteorological observation, AWS, and agro-meteorological observation, and automatic rain gauge monitoring network, and aviation in short or introductory of these sections. We are having one surface instrument divisions. So mostly it looks after the maintenance, procurement, and installation of instrument at a different sectors like aviation. All the meteorological instruments are installed at different airports for forecasting of weather. This is very much useful for the aviation and flight operations, and for transportation also. Very road transportation is also involved. So weather is observation is very much important for them. We are having automated weather stations around all over India, and automatic rain gauge stations are also there. Continuously we are installing for district-wise more accurate forecasting. And we have radiation networks and Antarctica cells, where weather observatories are there at Maitre and Bharati, maintaining those stations by installing advanced instruments which will be helpful to the expeditioners for different study, because Antarctica is a very harsh environment. Negative temperatures are there, so accurate forecasting is required before the field team visiting to the site for experiment. We have a workshop unit where all the classical or traditional instruments still we are manufacturing, calibrating it, and supplying to the different observatories which is required for accurate observations. We are continuously taking these observations and taking its maintenance also, and upkeeping those instruments for accurate observations. And test and calibration facility of classical traditional instruments also we are doing. An automatic weather station like TVRG, which is used for rain measurement. That instruments also digital instruments like digital thermometers, ATRS we are calling it, atmospheric temperature and relative humidity sensors, that are calibrated in our lab, where this facility are national level standard calibration facilities are available. Also, we are having portable standard this calibration facility, where we can carry this standard instrument to the field, and we can check our instrument over a periodic time, how its performance, how much it is differ. Accordingly, we are setting the offset for matching with the standard instruments. And SID, the surface instrument division, also maintaining the surface observational network, and also this is high wind speed recorder and ocean monitoring network. So these all the upkeeping and continuous monitoring, calibration, and maintenance are looking after by this surface instrument division. So these are all the instruments available, from the traditional classical instruments to the state-of-art automatic weather station. You can see different classical instruments what are we are manufacturing in our workshop available at Surface Instrument Division, CRS Pune. We are having, these are classical instruments, thermograph, hair hydrograph, then wind cup anemometer, cup counter anemometer. This is our rain recording instrument, and these are the automatic weather stations. Nowadays, we are installing at a different remote places for unmanned stations. So these are radiation instruments, and this is a digital standard barometer for pressure recording, and this is the classical barometer for pressure recording. And you can see this is the visibility instrument, and you can see the detail in zoomed manner, one by one instruments each. Okay, so this is the basic introduction about our surface instrument division work and how we are maintaining the observatories and its observational network. So the synoptic method means what is this is the method technique by which we are collecting different surface observations. So synoptic observation is an important tool for studying the atmosphere. These are the observation of different element. These observations are then plotted on the different types of charts. Analysis of these charts will be helpful in understanding the three-dimensional pictures of various atmospheric systems. And the synoptic observation, what it called, that we are regularly collecting this surface observations at a different interval, starting at 00 UTC, we can say at a 5:30 early morning, and it is at a regular interval of 3 hour regular interval. Observations are we are regularly recording in a day. So what exactly we are collecting in synoptic observations: pressure, temperature, water vapor, or it's a humidity, wind. And this first three element, we can say these are the scalar quantity. And wind, it has two sections. It is one speed and wind direction. It is a vector quantity. So it has a two part. It has magnitude as well as direction. That's why it is a vector quantity. Remaining all three are scalar quantity. So the observation what we are recording at observatories are synoptic observations, and the recording standard times, we can say, as we can say, there are 8 observations we are recording starting from 00 UTC at an interval of 3 hours. And these observations are act as an input to the different systems and for weather forecasting, and further analysis is possible. Once it is observed, it is forwarded to our next RC, the regional centers, meteorological centers, from the observatory levels to the where the data analysis climate division is available. The data is forwarded up to that section timely, so that further analysis is possible. So most importantly, out of all these observations, 3 ETC and 12 ETC are most important observations. Why? Because at a 3 ETC, we are concluding the minimum temperature and the total 24-hour rainfall at this hour. At a 12 ETC, it is maximum because it gives the maximum temperature of the day. So that's why these two observations are very much important, where minimum, maximum temperature and the total rainfall, 24 rainfall, cumulative rainfall are reported. So from the word observation, synoptic observation, then we have already discussed what is the observer, the meteorologist who recording actually the instrument who is operating is observer, and then the site where these instruments are installed are called as observatory. These are the special scientific area where the instruments are installed. Generally, we cannot install our scientific instrument at any place to record this valuable data. It required a specific height and a specific means some places where there is means it is free from tall trees and high buildings, and mainly that waterlogging areas, drainage, and that will contaminate our natural means atmospheric temperature and all these. So the site where we are recording these observations are generally, it is called as observatory or meteorological observatory, where we are installing our met instrument for recording temperature, then pressure, rainfall, and wind speed, wind directions, and these are the area. And each instrument having certain its requirement. You cannot keep any instrument at any place for recording these values. Each instrument required a desired height for accurate atmospheric parameter observations. So here is an example of actually well exposed area is a land is a highly essential for this type of measurements. So generally the minimum nowadays we can see that this open spaces getting is very much difficult nowadays. So the minimum area here we can consider that a 55 meter north south and here it is 36 meter east west. That area is a minimum requirement, so that we can here it is also it is totally congested this much area means it is only considered the site where the instruments are installed. Then for observer calculation, sitting arrangement, office, and all this, that thing actually we need some more space. Here we are only consider the where the scientific instrument will install, that area only we have considered for minimum this much area is required for installation of our different instrument. And wire fencing, proper wire fencing is required for the safety of this meteorological instrument. And these are say graded form, it is found for easy to see where we can install our different. Here it is the location for sunshine recorder, and wind vane you can install here. Then like that it is made a graded form to see the where we can install our different scientific meteorological instrument in an observatory. So this is the observatory site where we can install the layout of a meteorological observatory, you can say. So we have already discussed regarding this hour of observations, and there are different observations are taken 8 different observations starting from 00 UTC at an interval of 3 hours. We are continuously recording in a day up to 21 UTC, and these are already we have discussed that 3 ETC and 12 ETC observations are very much important when there is a meteorological parameter minimum and maximum and rainfall is considered. And there is a order of observation also for meteorological surface observation in an observatory. There is a sequence of observation is there. And a observer, suppose he is reporting in a particular hour, 10 minutes before he must have to ready for these all observations. First, he has to record wind instrument, wind speed and wind direction, then rainfall using rain gauge, then different thermometers are available like maximum, minimum, dry and wet thermometers. Four thermometers are available in Stevenson screen. Stevenson screen is a special housing of our thermometers, and these thermographs and hair hydrograph, they are required a special environment housing for recording of these parameters. And we will see the Stevenson screens and or the housing of these the thermometers in our next coming slides. And there are some non-instrumentational observations are also available, like cloud height and types of cloud and cloud coverage and visibility. And these are generally in observatory. There are different types of observatory. Also, observatories are also classified into different types according to the number of observation the observatory is reporting. Generally, non-IMD observations like part-time observatories are also available. Like different other institutes are contributing their observations where they are only reporting 3 UTC and 12 UTC observations. But our IMD regular observatories, they are continuously reporting and 8 observations. But still there are some observatories where we are not having all these instruments. So they are reporting few observations in a day. So accordingly, the number of instruments or the number of observations, they are classified into different classes like class 1, class 2, class 3, and class 4. So these are different classification of observatories. According to they are reporting the number of observations and the number of instruments available. So this is the classification of observatories and observations. And in a so there are from here we have saw there are two types of observations. One is instrumentational observations and non-instrumentational observations, where instrumentational observations required wind instrument, rain gauge, and thermometers for these are instruments are available for reading. It is called as instrumentational observation. Where the instrument are not available means non-instrumentational observations, where observer is involved. He manually observed the sky. He reports the types of cloud he observed, and the cloud coverage, visibility. Also, the coastal stations are reporting the tidal, means the waves, the height of the tide, and the frequency of the tides they are reporting. That is also coming under this non-instrumentational observations. So the same thing we have discussed. There are two types of observations in a surface meteorological observatory. Instrumentational observation, where pressure, temperature, wind, rainfall, these are instruments are available. And non-instrumentational means observer observe, and he will report the visibility, a particular long distance site which is visible in a daytime, and the percentage of visibility as he observed during the time of observations. So he will report the visibility by its own observations, and manually he also observed the sky, the type of low cloud, medium cloud, and the high cloud are seen, and the cloud coverage, and the present weather, whether it is raining or it is cloudy or sunny, like that. And the wave observation we already discussed, that is the tidal observation, the height of the tide and the frequency of the tide. These are coming under non-instrumentational observations. So in instrumentational part, first we will see the wind, the most important parameter, that is wind. It's a vector quantity, and it has two things, that is a speed and the directions. So the wind, it is a air in motion which is expressed in terms of direction and the speed. What is wind direction? Suppose the direction from which the wind blows towards the station or away from the station, it is called as wind directions. And the speed, the rate at which air in motion instantaneously, that is the speed of wind. So here we can see the direction. It is 16 points. It is subdivided exactly: north, east, south, and west. On a digital wind anemometer, like we have ultrasonic wind sensors, we are getting direction in terms of these angles. Like north, it is wind is considered with respect to north, it is a 360 or 0 degree. Like that, it is that wind. In east it is a 90, then from south it is 180, then west it is 270. Like that, on a digital anemometer we are getting the angles from which the wind is blowing. Whereas on a manual wind we can classify more precisely, but we are have a level like this is a mechanical wind vane, where we can see that the wind is here, it is showing from north to south. Okay, so this is the direction, and this is the direction from where the wind is coming. So it is a mechanical, or it is a you can say it is a manual instrument. Here the observer needs to record manually. Once there is no recording, just he has to observe the direction from which wind is coming. Like that, he has to report. He can also report accurately, like it is divided into again the southeast, again one direction, like he can report the wind is from the southeast direction, like that. So suppose if it is in the direction this this one is showing towards this, then he can precisely say that the wind is flowing to the northwest direction, like that. So it is a mechanical wind vane, where observer needs to observe these parameters. Only here you can see the directions. And generally we are reporting this wind in terms of knots, and one knot we can say it is 1.853 kilometer per hour. Okay, so this is the instrument, mechanical wind vane. It is for measuring the wind directions. Okay, so it is installed around 7-8 feet mast. You can see this type of, actually this type of arrangements are required why a spatial area is required for observation. We cannot put our sensor at any level for this measurement. It required a particular height, like 10-meter masts are available, and that rain gauge is here. It is showing here. It is installed in the ground level. So each instrument having its desired specification, and you have to install at according to those criteria only for getting accurate observation from these instruments. So this is the instrument for wind direction. So here you can see a cup anemometer and cup counter anemometer is there, and an observer is observing the wind speed. What he is observing here, it is a IMD make instrument. It is a cup counter anemometer. It is installed at a height of, you can see, at a height of 10 feet. It is height, and three large semi-conical cups are available. According to the wind direction, it is continuously rotating. The speed is depends upon the wind speed. Okay, and what he is observing these readings. Actually, it is like the anemometer is like, it is you can say the speedometer with or what is our energy meter for current calculation. It is available in our house, so their readings are available. So he is observing, the observer is observing these readings, and how he is calculating the wind speed. First he is note down the what is the present reading. After some interval of time, suppose 3 minutes, what is the reading, the difference it will give the in kilometer or the knots, and you divide by the time, that is, it will give the speed of wind. So this is the arrangement and internal structure of a cup anemometer. These are all classical instruments and traditional instrument currently in use at a different surface observations and observatories at all over India. So in the previous two unit, that observer is required to record these parameters continuously. An observer is required, and to get these values continuously on a paper, means at any suppose a observer is recording observation at a 00 UTC or 3 UTC 8:30 in early morning. So that is the value at those instants only, the wind speed and wind direction. Suppose if you want to see what is the wind direction in between, suppose 180 ETC, how the wind and wind direction, there is no record available. So for that, this type of instruments like a Dyne's pressure tube anemograph, where it will record both wind direction and wind speed on a paper. So 24-hour, these records are available on paper. At any instant, you can see these paper and you can calculate or compute your wind direction and the wind speed. So this is the record available on paper. But in the previous two observations, a observer is required to measure the wind direction and the wind speed at the particular observation hour only. Those data available. To get the data over a 24-hour, this type of pressure drying tube anemographs are installed, where we are having this data direction as well as wind speed over 24-hour. Now, next is rain measurement or precipitation measurement. This is the ordinary manual instrument it is. And this is a fiberglass reinforcement polyester it is, we can say. And what is the area? The different areas are available, 100 and 200 square centimeter area. This is the area, and the diameter generally, the rim diameter is generally 15.9 centimeter. And how it measure, if you see in the next slide, if you see here, this is the internal of for this one is the funnel, and this is the area from where the water is into this funnel. And after that, this is the base of this ordinary rain gauge. And for that, we need a measuring jar. You can see a glass is there. It is the measuring jar is required, and this is the base and the collector, rain collector, and this is the plastic which is inside this base. Okay, so exactly if you see the next slide, if we see here the schematic of this rain gauge, if you see for measurement around where there is heavy rain around nearly like 400 millimeter capacity, we need a 4 liter jar inside it, and where there is a less rain, maximum up to 200 mm. So this is the rain capacity of this collector. So here it is the arrangement. This is the collector area, and this is the funnel which collect the rainwater and directed into this plastic jar. And for the collected water, we are measuring at different intervals of observations. Like in a part-time observatory, so we are reporting at 3 UTC and 12 UTC. Evening 5:30 generally we are recording, and morning 24-hour, as we said, that early morning around one observation at 5:30. Then next is at 3 UTC we are reporting the cumulative 24-hour rainfall we are collecting from this jar. And for measurement we required that glass jar, measurement jar is required for measurement amount of rainfall. So that is here manual. Already we have discussed what is the difference between a manual measurement and required a paper chart. We have observed in wind measurement, where we are having a dying pressure anemometer. Anemograph is where a paper is there, where we can get a 24-hour wind speed and wind direction. Similarly, in the ordinary rain gauge, the instantaneous, when an observer went for observation, he will collect the that plastic collector, and he pour the water into a measuring jar. From there, the amount of rain he will calculate and report. But if you want that continuously 24-hour, how the measurement or how the rainfall is there, then for that we are having this self-recording rain gauge, where a recording drum is there, and there is a siphoning arrangement and a floating chamber arrangement is there, and this rotating drum, a drum is there, which completes its one rotation after 24 hour. Generally 8:30 we are removing this paper every day and installing reinstalling this paper on this drum. And this is a pen plotter is available. So 24-hour rain, it record continuously on this paper. Means the paper capacity means maximum it can record from 0 to 10 millimeter rain. After 10 millimeter, the water will drain from this siphoning arrangement, and again you start from 0, and like that it continuously record the hourly observation on this paper. Means we can calculate the amount of rain at any instant of time from this paper. So the internal of this self-rotating rain gauge, it looks like this. This is the paper where rotating drum, where we are fixing our recording paper, and this is the pen arrangement. It start from 0, it go up to the maximum 10 millimeter. Once 10 millimeter, this is the siphon assembly. It release water. Once the water is released, this pen again come to 0 level. Like that, it continuously it record the rain. We will see one recording is available. This is the internal of this self-recording rain gauge. If we see that this is the pen, you can see here it is the 0 level and 10 millimeter recording arrangement at this drum, and this drum completes its one rotation in a 24 hour. And this is the collector funnel connected to this tube, and there is a small opening, and this is the floating chamber. So slowly the water will accumulate, and the float will slowly rise up. Accordingly, it is connected to this pen, and pen will raise its level. It will go up to maximum 10 millimeter. Once 10 millimeter it reaches, there is a water releasing arrangement is there. It flushes the water. Accordingly, slowly this float system come to down again to the 0 level. So it continuously record the rain by using we will get the 24-hour rainfall on paper. So this is one example of how the rain it is recorded on a paper. So generally between 8 to 8:30 we are sifting this paper. Here it is 8 morning, and this is the 9, like that it is a continue next up to the next day. and here you can see the paper is fixed somewhere in between 8 to 8:15, and after that this is the test. Means once you fix this paper to drum, then we need to pour water. We have to check whether the pen freely it is moving from 0 to 10 millimeter or not. So this one is the first one is the test thing. You have to check whether everything is freely moving or not. Otherwise, we will not get any record for. We will miss the 24-hour variable rain data. So there is a check. Initially, we have to check that whether our pen is moving. We are pouring around 10 millimeter water, so it has to move from 0 level to 10 millimeter, and after 10 millimeter it lose water, so again it has to come to the 0 level. So here you can see there is a small rainfall at around 8:45, around 1 millimeter, 2 millimeter rainfall is there. After that there is no rain up to 12:26 around. After that here we can see around slow rain, sudden rain is there for 0.3 mm. After that there is a slow diesel you can say, and it is slowly increased up to the 0.4 level. Here again at around 6:14 around there is a sudden rain of 10 millimeter. After that it come to down and it went up to here it is around 9 mm rainfall. After that no rain. So like that the 24-hour rainfall it is recorded on paper. So the difference between an ordinary rain gauge and here is, in ordinary rain gauge the water is collected in a jar and we need a observer to measure this rainfall. So this is the difference between a self-recording rain gauge and a ordinary rain gauge. So next is the Stevenson screens. What is we have discussed, each instrument required a special housing or the special um, what we can say that special specification heights and all required for accurate measurement. Here you can say there are two types of Stevenson screens are available. One is a single Stevenson screen. This one is a bigger, is a double Stevenson screen, and this one is for housing of all the dry, wet, maximum and minimum thermometer are generally housed in a single Stevenson screens at a height of 1.25 meter height from the ground. 1.25 meter generally the thermometers are kept at a height of this for accurate measurement. And similarly, the hair hydrograph and the thermograph are kept inside this double Stevenson screens, and it is generally the same height what we have discussed for this. It is also fixed at a height of 1.25 meter from the ground level. Here we are having means thermographs. So there is a difference between, what is the difference between thermometer and thermograph? We already discussed in ordinary rain gauge and a self-recording rain gauge. In a thermometer, we have to see, we have to record, note down what is the temperature. And in case of a thermograph, we are getting the temperature on a graph paper. That is the difference. We will see in our next slide. So these are the housing of a thermometer and a thermograph hair hydrograph. So this is the Stevenson screens what we have discussed, the where you can see here there are 4 different thermometers are kept inside it. Single Stevenson screen. The previous slide, if you remember, see this is the housing where there is no thermometer, and here we have the 4 thermometer fixed on this single Stevenson screen. Dry thermometer, wet thermometer, and maximum and minimum thermometer. So from the dry and wet thermometer, these two reading are we are using to compute our vapor pressure, relative humidity. Mostly these are computed from these two readings at different hours of observation. We have already discussed that these here an observer is required for accurate measurement of this. If he will record accurately dry and wet temperature, he can calculate relative humidity and vapor pressure exactly. So the here the accuracy is more important. That's why expert observers are generally working for a meteorological observation. They are collecting accurate observations from these surface observatories mostly. So what is the difference between these two thermometers? Dry and wet thermometer, they are almost the same. And what is the difference? In dry, we have there is no water and this thread, mostly in generally we are calling. This is a cotton thread. Generally, we are calling it is continuously. It is means connecting to this. There is a water jar, and from this water jar, it is connected to the bulb is connected with there is a thread, and it continuously evaporating that water, and it gives the wet reading. So these two thermometers are same. Only difference that this bulb is connected with the thread, and that thread is deep inside into a water jar, small pot. And this is the thermometer for maximum temperature and minimum temperature. Generally, minimum temperature we are getting it recording at 3 etc. We are getting the minimum, and evening 12 etc. We are getting the maximum thermometer. After that, it required to reset for next day observation. These two thermometers are generally we have to reset for next observation. Otherwise, it will record the same, means further maximum if it will arrive, it will record. Otherwise, it will stay at the same point. So for new readings, we need to reset these two thermometers. So what is the difference in this two thermometer? Here it is a mercury maximum thermometer. It is a mercury thermometer, and the minimum it is a inside the liquid is alcohol. And what is the second difference is that you can see in a maximum thermometer, here a constriction, or you can say a bend, when there is a change in the temperature, maximum temperature, when there is a rise in temperature, this mercury will push this mercury over this bend, and the temperature go up to the maximum level. But when once temperature decreases, the mercury which is crossed this point, it unable to move back. So it up to you reset, the observer reset that temperature, it record the same value. So that's why resetting of this maximum thermometers are generally required. And what is the difference in a minimum? In a minimum thermometer, there is a dumbbell shape. One indicator is there. With the decrease of temperature, it pulls these dumbbells towards this bulb. But when there is rise of temperature, it will not disturb this. The arrangement is like that. Only it will pull the this dumbbell shaped indicator, and it will give the minimum temperature. So once you record this minimum temperature, you need to reset for next minimum. So the difference is that here inside it mercury is there, and the minimum thermometer, it is alcohol with a dumbbell shape arrangement inside it. So that is the difference between the minimum and maximum thermometer arrangement. And we already discussed the dry bulb and wet bulb. They are both are same. The only difference is that here in wet bulb there is a curtain thread is it is deep inside a water pot. That is the difference. It gives the wet reading, and this will give the dry atmospheric reading. And from these two reading, we are getting a relative humidity, dew point, and vapor pressure. We are getting from these two reading. There is a computation table. We need to refer the table to get this values. For soil temperature measurement in agrometeorological observatories, generally different thermometers at an inclination of 120 degree, there are different thermometers are installed at a depth of 0 centimeter, means surface level, then 5 centimeter, 10 centimeter, 15 and 20 and 30 centimeter, like that. Different thermometers are installed at the ground to get that temperature, soil temperature and soil moistures at a different level of soil. These are mostly useful for agrometeorological advisory for farmers. They are very much useful, these data for the special types of crops they are cultivating. So this data is very much useful for agrometeorological purpose. So here you can see a observer recording the different thermometer reading at a different level of soil. So we already discussed thermometers. So thermometer and a thermograph, what is the exactly difference is that here we can get the 24-hour value reading on a paper. What is the difference is that thermometer, it will give the instantaneous value, where observer went up to the single Stevenson screen and he will record the values at that point. But what is the difference in a thermograph, like in a self-recording system? And we have already saw that deep dive pressure anemometer, where there is a cup, this a drum arrangement, and there is a paper is there on that, and we can get this data for 24-hour recording over a paper, and there is a pen arrangement is there. So how this the close view of a thermograph, you can see how it is actually working. So if we see, this is the close view, or it is the instrument is already completely dismantled. You can see this is the drum, which is complete. It's a one rotation in a 24-hour, and this is the pen arrangement, where there is this pen is connected to a coil. And what is this coil? It is a mix of different element, or we can say it is a mix of invar, bronze, steel, and brass, and different elements. So with the rise of temperature, this coil expands. With the expansion, this coil is connected to a lever and a pen arrangement. So this lever change its position. With the change of temperature, the coil expands. So accordingly, the lever changes position. Accordingly, the pen changes its position. So it will record the temperature at that point. Continuously, it is with the change of temperature, like with the decrease of temperature, it again contract. Contraction will give again changes in the lever position. Lever change the pen position. So accordingly, the decreased value of temperature is recorded on this paper. So this is the simple. You can see the coil, and these are the pen nib and all arrangements. How it exactly, it is a very simple instrument. And the internal block diagram, you can see this is the coil, and it is attached to a lever, and lever is connected to a nib, pen nib, and pen is connected to the drum. With the change of temperature, the coil expands or it contracts. The expansion or contraction will change the floater position. It will give the recording on, or the mark on the paper. We can see a thermograph recording 24-hour value, and it is similar like other charts. We are generally shifting at 8 o'clock or 8:30 in between, and with the rise of sun, you can see that the dry temperature, it is slowly raised around, it is maximum somewhere. These are the spikes we have received at around it is 12:30, and one more secondary maximum, it is around 3:46 around. Again, there is with the sunset, the pen come down, and in the night time it is almost a constant. You can say the small variation in night. But so with the rise of solar activity, sun activity, so this is the rising plot, and with the sunset activities, you can see the downtrend on this paper. So this is the daily variation of this um, thermometer, thermograph. So what is the difference between a thermograph and a chart recording and a absolute instrument? Absolute instrument require a observer, instantaneous observations he need to record, and a graph paper where we can get the 24-hour value. That is the difference. So we can, from here we can 24-hour temperature we can also compute, and 24-hour rainfall. Like that, we are having our air hydrograph, humidity recorder, like that our thermograph. It also work almost similar, but what is the difference? Here the difference is that the arrangement, everything is same, but here the sensor or the sensing element, you can see the bunch of hair. So our hair also elongate, or it contract with the change of atmospheric humidity. So it change its structure, and with the change of this lever will respond to this change, and accordingly the plotter pen change its position. So it record the 24-hour humidity. So this is all about our instrumentational observation. There are certain type of observation we already discussed, that are cloud observations. There are different types of clouds: low cloud, medium cloud, and high clouds. And that is also again classified into high clouds are different types. They are available at a height of 6 to 18 kilometer, cirrus, cirrostratus, cirrocumulus. Then medium clouds, it is available in between 2 to 8 kilometer, altocumulus, altostratus, nimbostratus, and low clouds are classified into 0 to 2 kilometers, as these are stratus, cumulus, cumulonimbus. So these are all types of clouds. Generally, a observer in an observatory need to observe by its own means manually. He has to observe. There is no instrument at present available at observatory level. But for different airports, we are having different types of ceilometers. Laser ceilometers are available, where we can see the height of the lowest cloud at different airport levels. So this is the difference between a cloud observation at airports and a observatory. So similarly, the visibility observation at observatory, exactly a visible for horizontal distance, exactly we can say a observer can means in a daytime he can see. So it is variable from observer to observer and his eyesight, exactly. So this is the manual observation at an observatory, whereas at airports we are having different visibility instruments are available. Present weather instruments are available, which can accurately gives the visibility and the current weathers at different airports. So that is the difference between this visibility observations. These are totally at observatory level. They are observer has to report manually what is the horizontal long light. He can observe a hill, or he can observe a light pole, or a mobile tower. At a, he know the what is the distance of that tower or a pole or a hill. So accordingly, he will give assign the visibility of that area. So after this all, this is the one more instrument is sunshine recorder, and it what it will give the maximum daylight hours or a bright sunny hour of a day. So it is very simple instrument, and you can see a hemispherical glass bowl is there, and there are different types of charts. Actually, what exactly it is doing, we are fixing different this cards below this glass hemispherical structure, and simply it will burn out the sun rays. It concentrate on the particular columnated at a particular point. It just burn out that area, and the length and the width, it will give the solar means the duration of day brightness is computed from this. And there are three different cards. It is here it is available. Long card, it is for a summer. And similarly, we are having the salt carved car is also, it is for winter. And straight, it is for generally for it is used during March to April, or it is used in September to October. During these seasons, the different season, these cards are using to compute the duration of a bright sunshine. So the close view of this instrument and these cards. Very simple instrument it is. Likewise, the last is here pan evaporator. What is exactly? This is a instrument which is we can say it is a circular pan of it is a diameter of 122 centimeter, and what exactly it will give the amount of water it is evaporated, or the amount of rainfall occurred. The amount of there is a fixed reference mark is there, and it is covered with net. Why? Because the water may disturb with the birds or animals around may use. So that's why it is covered with a net. A thermometer is installed over it to get the surface temperature, and also what exactly during rainy day, sunny days, how much water evaporated. So up to that mark, we have to pour amount of water. So that will give the amount of water it is evaporated. And during rainy days, we need to remove the amount of water from this instrument. How much water you have removed, that will give the amount of rain. So it is an alternate instrument to measure the rainfall or the evaporations. So this is the structure. of our installation, you can see it's a block diagram of this instrument, and generally it is covered with a wire mesh for not to disturb this water level, and thermometers are generally installed to get the surface temperatures and all. And this is the arrangement for evaporation and rain measurement and alternate instrument. Next, if we come to the maintenance and inspections regular required for accurate measurement.
Dr. Patro,
Yes,
next
sir.
lecture is at 12:30. I
Yes,
think,
sir. Just 5 minutes. I will conclude. This is the last part. So if you see the maintenance part, this maintenance, inspection, and use of this instrument, it is very regular inspection is very much important for accurate measurement, and a timely these instruments are cleaned so that we can get the accurate data. And regular cleaning of, suppose a rain gauge is there, it is covered with a tree or nearby is branches, it is covered rain gauge, we cannot get proper rainfall and all. So the timely maintenance of these instruments are highly essential, and calibration is highly essential for accurate measurement of these instruments and the data. Okay. So with this, as the time is over, so we can conclude our discussion on this topic. So this is all regarding the basic weather elements and their measurement using different classical traditional instruments. Thank you.
audience, one or two quick questions. If you are having some questions, you can ask. I think audience, no questions are there.
Okay, sir.
Okay, I thank Dr. Patro for his excellent talk on basics of weather instruments, elements, and the measurements. Thank you. Next
Okay, sir.
class will be at next lecture will be at 12:30.